Hello everyone, February 27th. All right, although it's late today, I finished work early today. I think I finished around maybe just a little bit past 9. And then I watched lots of videos. It was good. It was good. Because the Premier League happened 2 days ago, yesterday. So, and I didn't have time back then, so I watched all the games I need to watch today. It was good. It was good, and a few tennis, and a few new AI. It feels like every week there's a new AI model dropped, right? And then their performance getting better and better. Um, we're getting closer to something. I feel like getting closer to something. Right? What does that mean? I don't know. I'm not even gonna speculate. Well, the one drawback of doing it here right now is pretty pretty tired. So there's good parts of just watch the videos first and then do this. You kind of feel relaxed, but on the other hand, it gets really late and I'm tired, so that's definitely not something good. All right, shortest common super sequence given two strings. Return the shortest string that has both S1 and S2 as subsequence. If there are multiple valid string, return any of them. String S is a subsequence. If yes, so basically we want to find the shortest string that include both as subsequences. So we have A, B, A, C, and C, A, B, right? Maybe we can find the maximum common sequence, longest common sequence, and then whatever it's. So these we keep. So this one will be just C, A, B, A, C, right? So longest common subsequence, we need to know what they are. So not just finding them, but also know what they are, right? And then they will be occupying the space. And the rest I can just, just put them in. Alright, how do I find a longest common subsequence? I think it's two arrays, but that's the length, right? That's the length. Now I do remember there is a way, as you're going through the length, you also record. So basically, if I remember, is for each one we'll check every single one. If it's not the same, right? If it's the same, right? If the two are the same, then we try the ones before and then we plus one, right? If the two are not the same, then we will try the longer of the two, right? But how do we actually find the subsequence? We find a subsequence by, I don't know, mapping? So like if we do it with this, right? Let's say we have 4 rows and 3 columns. Right, so we have C, A, B. Actually, I believe usually we do this. We get an extra. Then we get an extra to make the DP easier. Right, so we have A, B, A, C. Alright, so All of these, I believe, are zeros. Right, so we have A, so we compare to C, doesn't work. So when it doesn't work, we will try the previous match, right? So just so the max of this or max of this. So this will be 0. It's equal, then we will do the previous. 1, and then this will be so this will be 1. And then this will be 0, and this will be 1. This will actually be 2. This will be 0. This will be 1. And this 2. This will be 1. This will be 1. And this will be 2. So the answer is 2, right? Okay, now how do we find back where we have the match? Oh, I don't remember. Oh, arrows, up or down? Yes. It's arrows and the diagonal. Yep, I remember. So in this case, doesn't really matter, so I just do whatever. I just pointing up, right? When it's the same. Ooh, when it's the same. It should be 2 directions, right? So in this, it's 2 directions. And this is going to be diagonal. And this is going to be pointing this way. This, again, 2 directions. This will be, because it's 1, so it'll be pointing up. This will be pointing diagonal. Here, it's again 2 directions. This will be diagonal. This will be pointing up. Here is going to be diagonal. This is going to be 2 directions because both are 1. And this is going to be pointing up, right? So our job is to start from here and keep going. Now we see a diagonal, that's a match. Okay, so we say we have a B. And this is also a match, so we have an A. And we need to record the indices that match for the first one. So the indice for the first one that matches would be 2. No, for CAB. Right, the matching index is 2. And then for ABAC, the matching index, this is 0, 1, 2, 2 as well. And now we match to... Oh, wait, hold a second. 1, that's not 2, that's 1. This is 1, and then we have 1, then we have a 0. Oh, it's because we added 1. Yeah, that's why. Yep, so it makes sense now. Okay, so now we have the matching, right? But what if you hit something that's go 2 directions? But I think if it really goes 2 directions, we just have to go 2 directions. There's no other way. Right? There's no other way. But I am going to fill out this. It'll be reverse order. Reverse order, which is fine. So basically, if you do this at the end, I think whichever works, right? If it really comes to go both ways, you just follow through to one of them. I think that will work. Okay, so now we know what they are, right? So we know these will keep, so we put the others. How do we stretch this? Well, we count how many we have, so we know 1, 2, 3, 4. So it'll be 1, 2, 3, 4, 5. So we know the answer will be a 5. Right? Then maybe it can be 2 pointers. So we start, so I put 2 pointers, and we start, and yeah, we set one of them as a template, and the other one we just, so yeah, we set one of them as template, right? And we go for the other one, and we see before it hits the common one, everybody need to fit, right? Everybody need to fit, and then okay, yeah. So basically we're gonna have something, and then we have something's matching, something, right? And the others be maybe like this. So what we do is we know a pointer's not here, a point here and a pointing here. So for one of them before this, we put this in the answer. Now we hit here, right? And then the other one, now we can just add right after that. Then we add this. Okay. The next one, we will add everybody until this, and this will add everybody until this. And then we'll add this, and then we'll add everybody until we end. Okay. So now what we need is a way to do this, right? Then it doesn't matter. We can just, we don't have to go 2 directions. We just need a 1, because it says you can return anything. So we just need a 1 direction. Okay. So how am I going to represent? Basically, there are 3 scenarios, right? So let's call so let's call 2 is diagonal, right? 1 is going up, and I'm going to 3 is the other one. I just call it 0. 0 is going left. So we do this. Okay. Alright, so what we're gonna do is we'll first set up int m, What is this? This is longest common subsequence. Right, we'll have m rows and n column. Oh, +1. That's a -1. Alright, so for I equal to 1, I smaller than m plus 1, I plus plus. Right, and then for int j equal to 1, j smaller than n plus 1, j plus plus. And if str1 I minus 1 equal to str2 I and j minus 1, right? If the two are the same, then we set LCS ij equal to diagonal, right? Diagonal is 2. 2 is diagonal. Else, if, else. So they're not the same, right? Then we need to check the up or the left. So, okay, else if LCS up I minus 1j larger equal to LCS I j minus 1 to the left. LCS ij shall equal to, so basically it says up is larger, so up is 1, right? Go up, else ij equal to 0. That's not 0. Go left. Right, so we have that. So once we're done, we need to have two things. I don't know, man. It's going the other direction. Because if you append, it's gonna append from right to left. Well, I mean, I guess it's fine. It's just a little bit counterintuitive. Well, okay. So LCS1. We do a vector. LCS1, right? And we also need a vector. Call it LCS2. And then we're gonna go through this, right? We're gonna go through this. How do we go? We have I and j, so we go I and j again. So I equal to m, j equal to n, right? So we are at the bottom right corner, and then we say while I is larger than 0 and j is larger than 0, because we're going up, going left. So once one of them gets out, that's the end, right? So once both are good, what do? We say if, right? If LCS ij is equal to 2, right? If it's diagonal, then we'll record well, record its indices, right? So we say LCS1 dot pushback. Maybe I can do instead of a vector, can I do a deck? Do we have a deck here? I believe so. Yeah, let's use a deck. Then I can say push front, right? I can do push front, and I'll push front of what? This is going to be LCS1, which is the row, so it's going to be I. And LCS2 dot push front is going to be a J, right? And once we're done, I minus minus. Oh, I can do it inside, right? Well, minus minus J is also going to minus, so we go diagonal, right? So this is a diagonal. Okay, so if LCSIJ is equal to 1, right? So this is go up. Then I minus minus. Right, so this is go up. And of course the last one will be J minus minus. Right, so this is not go down, so go to the left. Go left. Right? So basically we walk this LCS matrix. If it point diagonally, then that's a match. So we record the match, then we move diagonal. If it's not a 2, it's not diagonal, that means it's not a match. Then we, depending on what the value is, we choose to go up or we choose to go left, right? So we just keep moving until we exhaust all the I and J. Now we have LCS1 and LCS2. So they tell me where the longest common subsequence is between the two. So now what we need to do is reconstruct the string by putting everybody like the left. Okay, so I think we can just do a string directly, can we? Right, I can just say std string res, right? And we can say while LCS1. Oh, I can use a stack. I don't have to use a deck. I can use a stack. Yeah, I can use a stack. I'm pretty sure a stack is a better option, at least faster. Right, push back. Yes, I think I can use a stack. Now just say dot empty, right? While it's not empty, right? While it's not empty, and we're gonna put every letter to the left, right? To the left of the top of LCS1 onto the result string. Let's say for int I again equal to int pre1 pre2, right? So that should be pre1 small LCS1 dot top, right? I plus plus. So we'll put everybody in there. So res plus equal to string 1 I for int j equal to pre2 j small LCS2 dot top j plus plus res plus equal to str2 j. Once we're done, this res will plus equal to str1 LCS1 dot top, right? And then LCS1 dot, well, pop this, LCS2 dot pop, right? So we pop them both. Then go back up. If it's not empty, I try to go through every single one. Oh, we also need pre1 shall equal to LCS1 dot top plus 1, pre2 LCS2 dot top plus 1, right? Once we finish them, we'll pop them, right? And then next I'll do the same. So once we hit everybody, now LCS1 is empty, right? It's empty. I have the next one, so I need to do one more round. Say for, I see, I should add one more. Oh, it's not push back? Push. Wow, it's just push and pop. Alright, so at the end, we need to push the AND signal as well. So LCS1 dot push so we're pushing here, which is the biggest one, a small, right? So when that's done and I get out, which is the top is gonna be small, right? So ooh, that's actually not pushing here, so it should be pushing here. Right, LCS1 dot push, I believe this will push M. LCS2 dot push N. Then we do blah blah blah, right? And then at the end, this is gonna push out as M and N. Okay, I think this shall do. Huh. Oh, I am not allowed to do it. Really? It's not a structure or union. Wait, what? Wait, remember I used this one before. Oh, hold a second. This is not right. Yeah, I don't know why I do both. It's kind of weird. 0, 1. So first use longest common subsequence algorithm to find the indices, right, of the LCS for str1 and str2. Then we combine, right? We take all the letters to the left of each LCS in the index in str1 and str2 and concatenate them together. All right, let's see. Oh. And we have a wrong answer. Wait, hold on. What the hell? Oh, I think when I push it in, I need to go minus minus first, because this is one bigger, right? So the actual thing should be smaller. That the actual index should be smaller. Let's see. This one work? Not really. Not really. Okay, how about this? How about this? We keep this because I want it to be so basically it's I minus 1, right? So window push is I minus 1. So it should be this minus 1 and this minus 1. Nope. But we fix one problem. Now we just have this problem. So maybe, I don't know. Should I do this? Oh, I think I know why. So it shouldn't be like this. It should be, well, it's top. The top is smaller than M. It's kind of the last one, right? If the top is smaller than M, oh, it has to be. Oh, hold a second. I just don't do it if LCS1 dot top is smaller than M, then we do it. If it's larger than or larger equal to, we don't do it. There we go. That's the one. So don't forget the LCS matrix has one bigger indices. All right, I'll run it. Hopefully we get it through in one shot. Oh, we did not get it through in one shot. I'm not quite in the mood to debug today. So this is pretty bad. Have B, 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 A, 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 B, A. B, B, A, B, A, B, B, B. So the longest subsequence is, I have B, 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 B. I have 4 B's. Or B, B, A, B. All right, what I'm gonna do, I'll use this test case. I'll remove this. Let's just, you know what? It'll be more interesting that we, we'll debug this. Although I said I don't want to debug it, but I think debugging is the easiest way for us to really get this one done. So I will get it str1. Okay, this is this. Okay, now we have str2. It's gonna be this. Oop. Okay, so that's the 2. Solution. It's fine. What's the name of the function? Shortest common. Okay, so it would be. Let me rerun this. Shortest rerun. So str1, str2. All right. So let's put the breakpoint here. And then we will build this. It is 28. Okay, so we build it. Now I come here, we do F5, go main, I'll run it. All right, let's debug. I want to see this. This is what I want to see. So we'll go F2, F2, okay. We also have the LCS. LCS, probably no good. So, can we see the LCS? This is not really helpful. You know what? I'm gonna quit it. I don't think it's right to put the breakpoint here. Let's put the breakpoint here. Okay, so we're gonna try it again. All right, so we hit the breakpoint. Now we have LCS1 and LCS2. So we have length 5. Okay, and then this is also length 5. So LCS1, we have 0, 1, 2, 6, 8. Okay, 0, 1, 2, 6, 8. Where is 0, 1, 2, 6, 8? 0, 1, 2, 3, 4, 5, 6, 8. Okay. And the other one is 3, 5, 6, 7, 8. 3, 5, 6, 7, 8. 0, 1, 2, 3, 5, 6, 7. Did I miss one? Huh? B, B, A, B, A, B, B, B. B, B, A, B. Oh, this is A. First of all, this is A. 3, 5, 6, 7, 8. 3, 5, 6, 7, 8. 3, 5, 0, 1, 2, 3, 4, 5, 6, 7. I don't have an 8. B, B, A, B, A, B. Oh, it is one small, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that doesn't make any sense. 0, 1, 2, 6, 8. 0, 1, 2, 3, 4, 5, 6. There's no 8. Oh, 8 is the out. My bad. My bad. 8 does not exist. Yes, 8 is the artifact. 8 is the artifact. So 0, 1, 2, 6. So 0, 1, 2, 6. Okay. This is 3, 5, 6, 7. This is 3, 5, 6, 7. So these are what we're looking at. So basically, we shall have a B, B, A, B. And then we need a, so that's the first B we hit. So the second B we have an A, now we hit a second B, and a third B, and before fourth B we have 3, and a fourth B and an A. So B, B, A, B, A, B, B, A. Okay, this output is exactly how I put it. Oh, it can be a shorter string. Oh. Holy crap. It can be a shorter string. Wait a second. Wait a second. B, B, B. A, B, A. B, B, B. Oh my god. I think my idea was not correct. B, hold a second. B, B, A, B, A, B, B, B. Oh. What? Hold on. Wait a second. So basically I have B, 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 and then B. And I'm just importing everybody in between, but what he says is different. So not just the common one. Hey, hold on. What is that? Basically, okay, so it's a different one. So basically we want to have a string, a short string, which if we run the longest common with it, we get this. And the longest common with this, we get this, right? That's what we want. So, okay, so we can say, let's start from one of them, right? Let's start one of them. And we just start modifying this. So we add stuff such that it can be this B, B, A, B, B, A, B, A, B, B, B will become a subsequence of this. Right, and then we can run the algorithm we have, and then we notice that currently we only have these to be matching. Right, we don't have these to be matching. So maybe that's the wrong way. So we see a B, right? And we say, okay, we have a B, and we try to match as left as possible, so we leave some opportunity to match. So we match this B, we match this B, and now we have an A, right? We have an A, so we can either insert or we can try to match this A. So I say, okay, I'll match this A, and then I'll match this B. Then I'll match this A. Then I have 3B left. So just put them at the end. Huh. Is that right? No, because I can foresee a scenario where it's cheaper to insert, right? It's cheaper to insert. We insert one and then everybody else will fitting. But hold a second. I match these. But there is another. We can also match this, right? There is another way to match. That's kind of another way to match. Right? This is another way to match. So if we match it this way, then we say B and B, right? So before the next B, I need to put an A, then I have B. Then, before the last B, I have an A. But that A is actually matched, so I can just do two A's. But no, yeah, it doesn't work. Oh. I just stand up. I'm a little bit sleepy. It's not as straightforward. Yeah, basically we say when I have a different, so we can either insert, right? We can either insert or we ignore. We'll try to see if we can find a match for this later on. I don't know. Let's look at the hints. Alright, so we have the common subsequence. Yes. Wow, this is not really helping. Ugh. Because the common subsequence for this is just a bunch of B's. Well, I mean, honestly, bunch of B's. We can retract this to know. Yeah, we got that's the longest common subsequence. Okay, so I can run on one of the first string, and then I get the ones we need. To put like these A's need to be put these A's in it, and the second one we have, similar. Right, if we all try to go as left as possible. Yeah, but then how to find the combined once we have those. So they are the same position in the start, we just use those, right? And if they are not in the same position, right? So basically, the most common is we have something to the left, something to the left. Do we run that one more time? Not really, because we so basically we go, and then we have a stretch and a stretch to have the next matching letter. So now the goal is, can one of the stretch, if we move down again, to make the stretch bigger, because in this case we don't have a matching, right? So we can say I'll look down to see we have another one that's the same. If we do have another that's the same, then we have a new part to match. And for the other one, I also go down. It doesn't really make much sense, honestly. So we want to start. Yeah, that's not the start. Let's go from the last one, 6 and 7. Okay, because they're all towards the right. So 6 and 7. So let me redo this. So I believe is this, and this. So let's look at the last one. Okay, is the last matching. So there's no more to the right. So whatever is to the right, of both, we can put them together. Yes, that is correct. Whatever is to the right of this, we can put them together. So basically this means what the hell? All right, so basically we have this B matching. So whatever to the right, because if there is another matching, it will come into it. But because there's no, that means we can just put everything to the right of here, everything to the right of here. So that's going to be an A. Then we put this B, right? Then we move all the way here. Now we have this B and this B. Everybody in between, A. Then we have a B. Then we have another B, right? Then we have this B, so we have this A. Then we have a B. Then we have A, B, B. But I feel this is still not right. A, B, A. Right, and then we have B, B. A, B, A, B. Yeah, that isn't that the same as mine? Should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, this is way more than 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's one more. And this is also 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. It's actually not that much difference. Dude, this is exactly the same. That's not right. But I feel this logic is right. Right? You have the last one in this LCS match. So whatever to the right is never, it has nothing matching. Right? It has nothing matching. So I put them all in. So I do believe this BA should be correct. And then for the rest, yeah, so we have this B, and then we have this B, right? Now the ideal is if there is anything in between that can be matched, nope. Because if you look at this, it just put these three B's towards the end. Right? It just put these three B towards the end. Because everybody else can be matched in this one already. Huh. Wait a second. I think you got the LCS wrong. The LCS should be B, B, A, B, A. That's the LCS. Holy crap. I think I got the LCS wrong. That's why this one doesn't work. How did I got the LCS wrong, man? Oh, because you're only picking the biggest. Oh my god, I know why. Darn. That was quite dumb. God, come on. Alright, so I need 2. Yep, I need 2. So basically one is LCS len, the other is LCS position. So basically we say position is diagonal and LCS len ij shall equal to LCS len I minus 1 j minus 1 plus 1. Here, oh my god, I cannot believe it. I cannot believe it. I got the LCS algorithm wrong. Shall equal to LCS I minus 1 j. Oh, I'm very, very, very unhappy. This is absolutely a self-inflicted wound. Could have got it done earlier. Damn. Now I don't have time to read because I'm so tired. By the time I finish washing dishes, I will be just wanting to go to bed. These are, my lord, these are LCS len. All of these are LCS len, including this LCS len. Use of undeclared. I have one more undeclared. This is also len. Alright, so we got this. And now all the LCS here, I think it's LCS position. Okay, let's try it again. I'm not sure. Just try it. Still the same idea. There we go. There we go. It's the LCS part I did not make right. Reset test cases. Let's test the other two. Yeah, it's supposed to be 2. I was using the position to run this. Of course it's not gonna be right. I was about to just like give up. Like, what the hell? How come this doesn't work, right? I was about to give up. And then I realized, wait a second, I got it completely wrong. You see? Now we're right. Now we are right. 39 milliseconds with 6%. That's pretty poor. But we at least got this one solved. I am so close. So close to just give up. Thank goodness I did not. Oh wow, look at this. So we save the effort of doing this. All right, I think we have a little ooh, that is right. So how do? We don't need these two, right? We just need one of them. And what we do is just hold on. That's gonna be interesting. So same as solution 1, but instead of recording positions, we're putting directions, right? In LCS position, we directly build the LCS as we go through the LCS algorithm. So what I mean by that is we don't do this. We do string here, and we call it LCS, and everybody will start with an empty string. Basically, I can just do that. No matching constructor, of course, because I think I have to do this. Oh wait, hold a second. No. It's this. There you go. And then we say if they are the same, right? Then I will do whatever is. So it will be LCS ij, right, shall equal to plus equal to, no, it shall equal to the current, so str1 I minus 1 plus LCS I minus 1 j minus 1, right? Don't do this. But how do we do this? Oh, the length. Oh my god, that was smart. Right? So let's do the size. Is large equal to this dot size. And then we say LCS ij shall equal to LCS I minus 1j. Right? And in this case, LCS, this is also LCS. So we build it along the way, which means we don't need this. Right, we don't need this. We already have the LCS, right? We have the thing. So we can just say std string LCS str shall equal to LCS m n, right? So we get the string out. Now we have the string. Then what we do is the same. We move everything until we so we don't need any of this. Right, so we have this. We also don't need this. We just, for int I 0. We don't even need int I 0. We can just say char. Nah, let's just do int I 0 small LCS str dot size I plus plus. And we put everybody before, right? So we get boom. We hit all of this before, hit it before, we put it in, we put this, move on, and then from this towards the end. Yeah, so I do need a ij again. I0j equals 0, right? So we say while I smaller than m and str1 I is not equal to LCS str. Let's call it k. Right, let's call it k. Right, so it's not equal to this. Then we say res plus equal to str1 I, no plus plus. Right, so we add all of those until we hit str is equal to this, right? Once it's equal to, we get out. Right, and we get out, we'll move this one forward, and now we do the same thing, j smaller than n, and str2 j is not equal to LCS strk rest plus equal to str2 j plus plus. Once done, j move forward, And then rest plus equal to LCS str k plus plus. Then we move on, and then we do the whole thing all over again. And once they're all done, we'll return. All right. Let's see. Let's see if this one, if we have any luck on this one. Nope. I need result not supported. What? There you go. We'll use this case and we'll use this case. All right. Let's test this new code. Oh, that was brutal. Things are not right. I'm not sure why. Really not sure why. I'm only getting half. How? Oh. Print debugging. Not the best, but interesting to see. BA. That is not correct. It have to be reversed. Oh, I see. Has to be reversed. Note that this LCS is reversed. Am I happy with this way? No, but don't think I have an option. Don't think we have an option. We'll just go from right to left, which is not that different compared to from left to right. That's even more poor. Oh, I need to add more after, right? Because I don't have. I see. Okay, okay. So we need to have a endpoint. All right, now we can hit this before. Yep, we need to have an endpoint. All right, that's not right. What the hell? How is it still not right? Oh, because those. Okay, so how about this? We do this plus, right? And then we go from right to left. We da, and then we have the last. K minus minus, and it's not equal to, this shall be right. Yeah, the sentinel should be placed here. Sentinel should be placed here. What the Alright, I don't understand. Oh, wait, I think you do understand. But we have an extra B here. I don't know what this is. Oh, I have the K minus minus here. So hold on. So I think I just do k because we are at his, right? We add everybody before. We do this, now we move on to the next one, right? So it's just don't do the last one. We say if LCS, now if k is larger than 0, then we do this. So we basically just trial and error. Trial and error. There we go. There we go. Yeah. Is reversed, right? And we add a sentinel. Yeah, we add a sentinel. The sentinel can help. The sentinel can help simplify the creation of the super sequence. So you don't have to like end it early and then do the thing, do the loop again. We have the sentinel there, we do it. All we need to do is just make sure, let's put this one as well. Make sure do not include the sentinel itself. All right, submit this. See, that was very disappointing. Oh, wow. We have memory. Oh, well, this is memory. Python allows it. Python allows it, but this one does not allow it. That's actually 2. Unfortunately, oh, why you do it that way? We can just build it, right? We just build it every time it's equal. Every time it's equal. Well, let me think. Every time it's equal, we take whatever is here, then we do that. Yeah, I guess it is not advisable because we're saving a lot of strings. Yeah, this solution times out. Not times out. This solution yields memory limit exceeded. All right, show me. What's the fast way? Memorization, bottom DP. Space optimized. Whatever, dude. Whatever. I'm sticking with my, which is pretty bad actually. Right, this one's actually not that good. We're at the limit. Right, we're at the limit. Because we do this. I wonder, because we use this to hold on, I have some idea. This one fails, right? But I have this idea. So in this solution, when I initially, oh my goodness, what did I do? When I initially do this, okay, have a 2 already. When I initially do this, let's not create stack, right? Let's not create a stack of LCS1 and LCS2. Instead, we rebuild the string, right? We rebuild the LCS string. So this will take advantage of the good part from both the first and the second solution. So when we build it, we still use this, the direction, but when we do here, right? When we do here, we can just say, we don't need any of this, right? So we just say std string lcs_str, and we can initialize it to be this, right? With a sentinel. And then once it's diagonal, instead of pushing, right? We are pushing. Oh, but how do we build a string? Oh, because you're pushing the I, which is the index. So essentially we're saying LCS_str will plus equal to str1 str1 I minus 1, right? And then I minus minus j minus minus. Right? Else we go this. So now we build a LCS string, and for the rest, I'm pretty sure we can use this, right? We can use this. So we don't need this, we can use this. Read definition of J. That's fine, we just reset them to 0. Yeah, let's put them in 1 right. Okay. Doesn't like it. That's fine. All right, solution number 3. Let's try number 3 on this one. Oh, it works. Well, I am working on this problem, number 1092. It was an old problem I solved before. 2019. I didn't realize it was a long time ago. And I solve it with this solution, which is, it's okay. We passed, but it's pretty bad performance. And I tried to hack it using this, which is building the string along the way, which is exactly the same as I used back then, because it's in Python, right? I just build a string, straightforward, but in C++ it doesn't allow. So now I'm combining the two methods. One is using the direction method to find what the next index should be, and we build a string instead of 2 stacks. I have high hope that this one will give me the best performance, and we'll see. And I'm very wrong. Jesus. Okay, so yeah, that's not how it's supposed to be done. This is actually even worse. We can hit 41 milliseconds. All right, I think the best solution will be whatever the editorial was talking about with this space optimized DP, like whatever the hell this is. And then yeah, I have no idea. Absolutely no idea. I mean, look, the DP table is This is just a length, right? This is just a length. Oh, it's filling, hold on, it's filling it out. If character match, take it from diagonal, so I get that. That's exactly the same as what I have, right? That's exactly the same as this part of the code. Otherwise, but here, it's building the super sequence directly. So if it's this, so I do that. And if it's not, I move up and I will take it. I take it and then I move up. I take it and then move up. Okay, so what it says is okay, this is different. This just says the up, dp to up is smaller than the left. Then I take, Then I take the smaller one. Unless we handle this also differently. I am not sure. Yeah, it's different. It's taking the minimum. It's taking the minimum. I am taking the maximum. It's taking the minimum. And then take the minimum plus 1. Alright, this is a very different approach. Very, very different approach. I think it deserves some more investigation. This is very different. This is definitely not LCS. Okay? This is not LCS. This is something else. But it's apparently working because by doing this, you're able to build a super sequence directly from the DP table. Whereas in my solution, regardless what it is, I always have to build an intermediate. Now here it's the string intermediate, and the other solution is similar. It's just a list of indices for the LCS. So I need an intermediate, and I build a string from the intermediate. This, I think, the intermediate is wrapped inside this DP table. That's very interesting. I think it deserves more investigation, so I'll look back into it tomorrow. I mean, it's so late. All right, that'll be it. I'll see you guys tomorrow. Adios.